Hi all, welcome to new class. Today's class is about block diagram reduction. The block diagram can be reduced to find the overall transfer function of the system. And there are some rules for the block diagram reduction. Let us study about the rules of block diagram algebra. First one is combining the blocks in cascade. So if there are two or more blocks which are in cascade or in series, then we can combine, that is, let the transfer function of these blocks be G1 and G2. Then we can combine these two blocks like this, that is multiplication of these two transfer function G1 and G2. Second one is combining parallel blocks or combining feed forward paths. So if the blocks are like this, that is in parallel form. So this is in this way and this is parallel form. So if the blocks are like this, then we can combine these two blocks, that is by adding the transfer function of these two blocks, that is G1 plus G2. Third one, moving the branch point ahead of the block. Suppose the branch point is at this point and now we have to change this point to this side. Then there will be an additional block here, that is 1 by g. So the transfer function of that block will be 1 by g. Fourth one, moving the branch point before the block. Suppose this is the branch point, then we have to change this branch point to this side. Then an additional transfer function of the block, that is a block should be added there, and whose transfer function is to be g. Fifth one, moving the summing point ahead of the block. So suppose there is a summing point before the block and we have to change this summing point to this side. Then an additional block with a transfer function of g, that is the transfer function of that block should be added. Then sixth one, moving the summing point before the block. Suppose the summing point is after the block, then we have to change this summing point to this side. Then an additional block with a transfer function of 1 by g, that is reciprocal of this transfer function should be added. Seventh one, interchanging summing point. Suppose there are two summing points, then if we want to change this summing point to this side and this to this side, then we can simply change by changing like this, that is the input is same here and here this signal is changed. Next is splitting summing points. Suppose there is a summing point with two or more signals, then if we want to split this summing point into two, we can just split into two like this. Next is combining summing points. So we can combine two summing points to a single summing point like this. Last one is elimination of feedback loop. Suppose there is a feedback loop. So this is a closed loop. So this is the forward path and there is a feedback path. So we can eliminate this feedback loop like this. That is, we can write g divided by 1 plus gh. This is R and this is C. And how this is possible? So this is C, and here we get this is C, R minus, so this is CH here, R minus CH is here, then the output of this block will be R minus CH into G. So we can write C equal to R minus CH into G, that is RG minus CHG, or we can write C plus CHG equal to RG. And here we can take this C outside, that is C into 1 plus Hg equal to R into G. So from this we get C by R, that is the transfer function equal to G divided by 1 plus Hg or Gh. Also, if the feedback loop is like this, that is plus plus, positive feedback, this is negative feedback. So if the feedback is positive, then we can write, so this is H, then R, then we can eliminate this feedback loop like this, that is G divided by 1 minus GH. This is C and this is R. So in this way we are eliminating the feedback loop. Let us do a problem. Reduce the block diagram shown in figure and find C by R. So this is the block diagram given. So this is the first forward path. Then there is another path here, and this is a feedback path. So here, to eliminate this feedback path, we have to change this branch point from here to here. So changing the branch point after the block means we have to add reciprocal of that transfer function here. So in the first step we have to change this branch point from here to here, that is plus minus, this is G1. So changing this branch point to this point, and there is a feedback path. This is G2. So we have to add reciprocal of the transfer function of this block, that is 1 by G1. Then G3 is there. Summing point is there. And we have to mark the arrows correctly. And this is C. Now we can eliminate this feedback path. Also we can combine these two blocks because they are in cascaded form. So after eliminating this feedback path, we get G1 divided by, this is minus, so 1 plus G1 into H. This is R. And now here G2 is there. Then summing point is there. These two blocks we can combine, that is multiply these two transfer functions, that is G3 divided by G1. Then C. Now we can combine these two parallel blocks, that is here G1 divided by 1 plus G1H. Then by combining these two parallel blocks means we can add these two transfer functions, that is G2 plus G3 divided by G1. Then C. Now we can combine these two cascaded blocks, that is by multiplying these two transfer functions we get the reduced form, that is G1 divided by 1 plus G1H into G2 plus G3 divided by G1. Now C by R, that is the transfer function, reduced transfer function is, or overall transfer function. Overall transfer function is this G1 divided by 1 plus G1H into G2 plus G3 divided by G1. Here we can take the LCM, that is G1 divided by 1 plus G1H into here G1 G2 plus G3 divided by G1. We can cancel these G1, then we get G1 G2 plus G3 divided by 1 plus G1H. So this is the overall transfer function of the given block diagram. Let us do another problem. Using block diagram reduction technique, find closed loop transfer function of the system whose block diagram is shown in the figure. So this is the given block diagram. So here this is a forward path, then here there is a feedback path, and here also there is another feedback path, here also another feedback path, and this is a parallel path. So here if we change this branch point to this point, then we will get a parallel path here. So first of all change this branch point to this side. Then by changing branch point to this side, we have to add a block with the transfer function of the same, that is G2 we have to add here. That is first one is R, then again summing point, then G1 summing point, then this point we have to change to this side, so here G2 is there, then summing point, sorry branch point, that is G4, then G3, then summing point, and this is here, so this one, that is H1 and G2. Then this H2 is there. And this feedback path is there. Now we can combine these parallel path, and before that we have to multiply these two blocks because these two are in cascaded form. So we get G2 G3 here and add that with G4. So R, then summing point, then G1, then this summing point is there. Now multiply these two and add with the G4, that is G2 G3 plus G4 is the transfer function of that block. Then C, H2 is there, and here these two blocks we can combine, that is these two are in cascaded form, so we can combine these two blocks, that is H1 into G2. And this feedback path is there. Now what to do? So there is a feedback path here and also here there is a feedback path, but we cannot change this branch point ahead of the summing point. Only we can change this summing point and branch point after the blocks. So let us change this summing point to here. Then we will get a feedback path like this. And again we have to exchange this summing point with this summing point. So first of all change this summing point to this side. So moving summing point before the block means we have to add the reciprocal of this transfer function here. That is, first one is R, then this summing point is here. Now this summing point we have to add here, that is plus minus, then G1 is there. Now we have to add reciprocal of G1 here, it is this one, 1 by G1, then H2 is there. Now this block is there, G2 G3 plus G4, then C. And this feedback path is there, that is from here. From here H1 G2 is there. Now this feedback path is there. So now we can change this to summing points, interchanging these two summing points. So just interchange these two summing points. R is there, plus minus, then this summing point, again this summing point, Then G1 is there, G2, G3 plus G4 is there, then C. Now we changed this summing point to this side. So this is 1 by G1 into H2. That is H2 divided by G1. And this is here. So H1 G2. This H1 into G2 is here. Because we changed this summing points. So this summing point is here and the blocks connected to this summing points are 1 by G1 and H2, and these two are in cascaded form, so we can combine, that is multiply H2 divided by G1, and this summing point is now here. So this is H1 G2 and which is connected to this point, and from here, and this H2 is connected to here. So we can connect like this, and this feedback path is there. Now there is one feedback path here. First of all, eliminate this feedback path. Then after that eliminate this feedback path, and after that eliminate this last feedback path. So while eliminating this feedback path, we get G1 divided by 1 plus G1 H1 G2. So after the first feedback path reduction, we get G1 divided by 1 plus G1 H1 G2. Now these two blocks are in cascaded form, so we can combine these two blocks, that is G1 divided by 1 plus G1 G2 H1 into G2 G3 plus G4. And there is another two feedback path, so we can draw like this, H2 by G1, one feedback path, another feedback path is this one. Now we can reduce this feedback path, that is this one divided by 1 plus multiplication of these two, that is G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 divided by 1 plus multiplication of these two, that is G1 into G2 G3 plus G4 divided by 1 plus G1 G2 H1 into H2 divided by G1. Then there is another feedback path. So here we can reduce this block by taking the LCM, that is these two denominators we can cancel, and we get G1 G2 G3, that is open the bracket, then G1 into G4 divided by 1 plus G1 G2 H1, then plus this term, and here this G1 and this G1 we can cancel, so we get G2 G3, then multiply with the H2 plus G4 into H2, and this is the last feedback path. So this is a unit feedback path, and we can eliminate this feedback path like this, that is C by R is equal to this G divided by 1 plus this one, that is G1 G2 G3 plus G1 G4 divided by 1 plus G1 G2 H1 plus G2 G3 H2 plus G4 H4 H2 divided by 1 plus this one G1 G2 G3 plus G1 G4 divided by 1 plus G1 G2 H1 plus G2 G3 H2 plus G4 H2. Now we can cancel the LCM and take the LCM, that is we get G1 G2 G3 plus G1 G4 divided by, here we have to take the LCM, that is multiply with this LCM, that is 1 plus G1 G2 H1 plus G2 G3 H2, then plus G4 H2 plus this term G1 G2 G3 plus G1 G4. So this is the transfer function, that is overall transfer function of the given block diagram. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.